Hello guys, it's hello guy, my one viewer. How are you doing today? We start in the next 3 minutes. Yeah, we start in the next 3 minutes. We start in the next 3 minutes. Thank you for joining the stream. I think we can start. I think we can start now. I think we can start. So last week we tried. We Hello Wayne. Hello Guitar. Thanks for joining. Yeah. So last week we were busy with Web2Vec, and I we created the training, the baseline notebooks, the training notebooks, the inference notebooks. So right now you have all the notebooks to train your Web2Vec models. Sadly, the Web2Vec models never improved our leaderboard score. So if you look at our leaderboard score currently, we are at 0.4289. 0.4289. You're still struggling to break the 0.38. But this was not from our Web2Vec. I've tried Web2Vec. I haven't tried to train it from scratch though. But I have tried and tried and tried and tried, and the best I could get with our Web2Vec was 0.54, like trying to improve the baseline models. But it seems like we have to train it from scratch ourselves. I will do it maybe in future, but not this week. So you might ask yourself then, how did you get the 0.4289? Because this is an improvement to what we had from the CTC models, from NVIDIA. So this 0.4289, where is it? This right here. I don't know why Zindi removed the submission name, but at least you could be seeing the submission we made. But this 0.4289 is a baseline Like I just went to Hugging Face and picked Whisper model that was trained, and yeah, so the 0.4289 is a baseline model from Hugging Face that was fine-tuned on previous Swahili datasets that I used. I never trained it myself, to be clear. So it's just a baseline model from it's just a baseline model from Hugging Face, meaning that maybe there are even better baseline models, Whisper models on Hugging Face that I haven't tried yet. Also, it means that at, out of all out of all the three architectures we have looked at, maybe the Whisper model is what the good performers are using. You can see most of them have 0.31, except the first place solution, the 0.25. Yeah, so next architecture we're going to look at this week is Whisper, and we're going to do basically everything, every procedure that we did in the previous architectures. The first thing is to create the baseline models, then create the training notebook, then create the evaluation notebook. But before I even continue, as I was doing my research, I realized that even Whisper is not the best automatic speech recognition model. So remember in our previous competition where we were learning about landslide detection, I showed you the team leaderboard for computer vision models. Also, we have a leaderboard for ASR as well. Yeah, and I realized after I was doing my research actually. So, if you look at ASR Hugging Face leaderboard, so we have an open ASR model, I mean a leaderboard that shows you the best ASR models, and you can see, um, yeah, and the one which we are very interested in is the multilingual one. But yeah. So you can see we have V4 multimodal instruct, Canary 1B V2, Whisper is number 3. So Whisper large V3. Yeah, and we are going to look. Oh, okay. Iko sawa sasa? Wayne, is it okay now? Cool. Like I was saying, just like in our previous competition, yeah, computer vision, we saw that there's a team leaderboard which like ranks all the best computer vision models, both transformer and CNN architectures. We also have a leaderboard for automatic speech recognition, and this was after my research during the weekend, and I found that we have this model called Canary 1B V2, and yeah, this was released like 8 days ago actually on Twitter, and it's actually so good. So it's a powerful 1 million parameter model built for high quality speech transcription and translation across 25 European languages. The keyword is European, so there's no like one fine-tuned for like Swahili, but we can actually fine-tune it. I think they provided us training scripts. I I think so. Um, we still use the Nemo toolkit as well since it's from NVIDIA. Um, yeah, training. Okay. I feel like there needs to be like a tiny notebook, but you should check it out. You should check it out. You should actually check it out. Yeah. So yes, visit the OpenASR leaderboard. I'll link it on the charts. Uh, yeah. But you can see number three is Whisper. So we need to look at Whisper. Web2Vec isn't even Web2Vec. Oh, there's also these parakeets as well. Multilingual speech to text model. It's also good. These are 600 million parameter multilingual automatic speech recognition model. Um, yeah, these are the supported languages. Also, no Swahili. Yeah. So you can look at these models and try to fine tune them as well. Yeah, trained on. Okay, yeah. So for the Parakeet model, they provided a training script. Looks like yeah, yeah. It looks like what we have been doing for the previous CTC models also. Um, yeah. So you should take a look. You should take a look. You should take a look. But today we are focusing on Whisper since it's number three. Yeah, it's number three, and you're going to create a baseline notebook. The problem with Whisper, it takes a while to like perform perform inference, especially if you are not using greedy decoding and you're using beam decoding. Beam decoding takes a lot of time. Greedy decoding, it takes like less time compared to beam decoding, but yeah. The result of my leaderboard, I got it using greedy decoding, so you can actually check it out. Yeah, so today we are going to create Whisper inference baseline, and tomorrow we create a training script for, I mean, training notebook for Whisper. The next day we create an inference. Actually, we already have inference, so maybe the Thursday stream we do evaluations. Yeah, inference baseline Whisper. Um, we are going to inherit a lot of things from the Web2Vec model. I also don't want this stream to like take a long time because the process we have talked about in our previous stream, so you can check it out. So we are going to, yeah, we're going to inherit a lot of things from our Web2Vec, especially the installs. There's no point of us like doing. There's no point of us like repeating everything we did in the previous streams. Yeah. So the imports. Uh, yeah. As it's installing, oh, we need to change the run type to like default. Okay. And remember the runtime constraints by the organizers. It should run on the normal T4 on Colab. So don't forget that. Um, you don't need fast AI, bro. Why are we installing fast AI? Yeah, I think that should work. Open as speedy from datasets, import, load datasets, and audio. I'm going to type for those who want to follow along. Or I'm going to share the link actually so that you can follow along as I type. I think the changes will reflect either way. So yeah, so that you do it together. For those interested. Yeah, I've shared the link on the chat, Twitch chat. Nice. Uh, from datasets, import load datasets. I also want Whisper stuff. So for um, Whisper. ASR, open ASR, leaderboard, Whisper. Auto model for speech to speech. Um, you can either use this. This is using, okay, auto model, auto processor. You can use flash attention as well. I think T4 supports flash attention, no? Uh, this is not the right. Does T4 support flash attention? Okay, it's not supported on T4, so we cannot use flash attention. Um, yeah. Touch compile, we can use touch compile. The Whisper forward pass is compatible with touch compile for 4.5x speeds. Okay. Pipeline. Anyways, you can take a look at this, at that write up, and yeah. You can use all these methods to improve your performance, but I'm going to use the normal one. This talks about chunks, long form. I don't think in our dataset we have like a long audio, but if we do, you can also use that. Yeah. So I'm going to copy some of things here. For example, all these. Actually, the imports first. We want to use pipeline. Pipeline is terribly slow, bro. Like, it's terribly slow. So I'm going to copy that. We already have this. We need torch as well. We need these. Yeah. We can copy all that. So here, set up the model and processor. But maybe you need the touch compile stuff because you'll see for yourself. It's it's terribly slow. Something that takes the Nemo one. Okay, so like we are not using pandas anywhere. We are using, if we are using pandas, maybe we could have used polars, but we are using the Hugging Face datasets because you're loading data from Hugging Face. But when we get a competition that will require us to use polars instead of like pandas, we are going to use it. Yeah. If today we use polars, it's to create the sample submission file, which doesn't make sense. because parallels is for performance gains, and creating the submission file does not like require performance gains. Yeah. So right now, at the most, like what we'll use the most is load data set, because you're loading the test data from like Hugging Face. Yeah. But nice suggestion, nice suggestion, nice suggestion. Uh, import panels, import, set up the models. We are not going to use this though, because we want to find models already fine-tuned on Swahili. Um, like we always do, the model name, dataset path, what else? What else? Yeah, also this device should be here also. And yeah. We correct these model ID. And also these. And we initialize the configuration. Yeah. Oh, model name. So we go to hunt. Man. We go to hunt. Okay. Search whisper. Large, maybe. Or whisper Swahili. I saw some Swahili ones. So we have these Hedrostone Swahili one. We can start with that. Is there another one? Or we can search by the most downloads. So we have this with the most downloads. Maybe you should start with that because maybe it's useful. We have this as the second with the most downloads. We can also use that. This for Swiss German. Whisper Small. ASR CV14 with 94 downloads. This is a small version. What error rate? 0.2513. Maybe you can, yeah, honestly, since this is just a baseline and we want to like see, so like we'll see the speed of the small one, then you can compare that to the large one later when you try it. So we can use this. So that's our model name. Our data set, we have to go to Zindi. Oh no, we already did this one, so like there's no way. If you don't know where we are getting the data set from, please. This doesn't have the data set. Oh, the train data set. Okay. I think you have to go to Zindi now. Welcome to the stream, my 5 viewers, man. Today we are not today. This week we are exploring Whisper. Since my best score on the leaderboard is from a Whisper model. Yeah. So this week we are exploring Whisper, and if you have missed, honestly, I've missed a ton of information. We have said even Whisper is not the best multilingual model out there. So if you missed that, make sure you watch the recording. Yeah. Yeah. So that's our dataset path. Even before we set up our model, but because the model takes a lot of time to okay, maybe the Whisper small model, it doesn't take that long to load. But yeah, the most sensible step here is to set up the data before the what is it called? before setting the data. I mean the model. So for this test data set is equals to the load data set we imported, and then pass in the data set path, pass in the splits test, yeah, and then we have to cast the audio to yeah. Thank you. And then we can even like use the you can even set the sampling rate here in the configuration 16K and use it here because you're going to use it multiple times. So yeah, sampling rate. And I feel like that's it now. Test data, yeah. Then you grant access. I showed you guys how to set up secrets. I'm not going to repeat it again. Yeah. So this data set doesn't take a lot of time, and I think even the model won't take a lot of time since it's always per small. It's a 967 million parameter model, and we saw Paraket is like around 600 million parameter. Yeah, maybe we need to fine tune Paraket, and it's actually good. And the Whisper Small imagine is 967. I imagine the Whisper Large. How many parameters? But there is a turbo version of the Whisper Large, which the parameters have been reduced. It was introduced when? Some time before? Yeah, this right here. So you can see it's a fine-tuned version of a pruned Whisper Large V3. It's the exact same model except that the number of decoding layers have been reduced from 32 to 4. As a result, the model is way faster at the expense of a minor quality degradation. Yeah, you can also explore these because remember we have the compute requirement as well from the organizers. So don't forget about the compute requirements. Nice. So the model has load, the processor has load. Now Whisper for inference. I don't know if like it was explained on the doc here on the model card. We need to like yeah. So like Whisper expects like all the audios to be like less or equal to 30 seconds. Yeah. I don't know if the so yeah. It has been explained in the model card. So Whisper has a receptive field of 30 seconds. So we need to pad or trim audios to fit in this window. So, and for longer audios, you just need to trim, or you can use this chunked long form. Actually, this is very informative. You should read this more. You should read this. So I'm going to link it on the chat as well. Yeah, because maybe not maybe I'm not going to go through all of these things. Yeah. So we need to pad or trim the audios. So we're going to do that. We are going to do that. So for that we need NumPy. Oh, and for those who have joined late, I shared a notebook link so you can actually follow while I'm coding because it gets updated automatically if I'm right. But I think it does. And then we need to set up our target length. I mean, to be 30 times, so 30 seconds times the sampling rate. CFG, the target length. Nice. Okay. Um, so for this, you're going to call it utilities, maybe. So we're going to define pad or trim. I hope the AI helps me here. We pass in the array and the target length, where the target length is initial, like by default, the target length created above. Um, so what this does is pads together AI, pad with zeros, or trim the waveform to exactly yeah. Okay, AI, thank you. If length of array is greater than target length, return array target length, else pad with yeah. So in uh, we need to pad now. Okay. Okay. Else return array. Is everything okay? So if the array is greater, we trim. Okay, and now trimming. If you have an audio that is longer than 30 seconds, then you're losing the extra information. So for that, just come to the model card. They have explained how to handle that. You chunk the long form audios, and then you process each chunk independently, and then you connect the results together. So if you have like 30 seconds, 54 seconds audio, you'll have the first chunk as 30 seconds and the other as 24 seconds. Hi Sadiq, thank you for joining. Thank you for joining the stream. Yeah, so you can go check the model card and see how to handle that. I'm not going to do that on stream. Yeah, and then define transcribed audio, or maybe I will. But I never saw like a lot of audios greater than 30 seconds. Maybe you need to do some EDA to ascertain that. We haven't done EDA at all in this competition. Post all waveforms to exactly 30 seconds length. Okay. Okay, the AI is trying, but remember the waveforms are stored in the audio key of the batch. So padded inputs is equal to pad or trim the function created, item array for item in batch audio. Yeah, for item in no. For item in batch audio. Yeah. And then processed inputs. Now we process it using the processor is equals to processor, passing the padded inputs, passing the sampling rates, return chances, padding is equals to true. Okay, but the padding has already been done, so you don't need this. And then we need to send them to the GPU because the data and the model need to like be on the same device. So we send the inputs to the GPU. On yeah. AI. Now we call the model to transcribe for us. So how do we do that? With touch no grad. So with touch no grad predicted IDs is equals to. Wait. Are you guys seeing actually? Yeah. Okay. Yeah. So that's the AI suggestion. Touch no grad predicted IDs is equals to model that generates. Also, we want to do greedy decoding because it's kind of faster than beam search. But by default it's greedy. By default it's greedy. Yeah. Transcription. We use the processor to decode the IDs, and then we save the transcription. Um, yeah. I feel like the AI has done. Yeah, and to like explicitly set it to greedy decoding, you do like. I think most people who have interacted with like LLMs have seen this argument a lot. Like they do sample. The sample just does greedy decoding. Yeah. The one with the highest probability gets chosen. Then transcription. Also, we need to like we want to process a little bit by cleaning the white space. I don't know how they are doing the whatever on it though. Does this ignore the casing? Okay, I don't know if it's affected by casing. Yep. Yeah. T does strip for T in transcription. Um. Yep. Nice. And now what we just need to do is map this function. Uh, transcriptions. I mean inference. So we have our test dataset that map. Then we map the function, batch size. Yeah. We need to specify the batch size on the configuration. It depends, honestly. You can use 16, you can use whatever fits on the GPU. So I'm going to use 8. Uh, yeah. Yes. Yeah. Hopefully, if you've done everything correctly, this should work. Fingers crossed. Fingers crossed, guys. Fingers crossed. First, let's make sure we. This is okay. If you have done everything correctly, this should work. So we should have like a new, let's say, feature name on the test dataset called transcription. Yeah, we have a nice progress bar. Hopefully it works. Fingers crossed, but I feel like it will take a long time. It will take a long time. Now imagine this is the smaller version of Whisper. Input type should be the same, and bias type should be the same. Okay. I think this is an issue of like data types. Um, I don't know where this is coming from though. Um, yeah. I don't know where this is coming from. We can ask AI though. Wait, test data sets. Hmm. I honestly don't know where this is coming from. Let's see. Padded trim, no. Transcribed audio, padded inputs, processor, done tensors, sampling rates to device, graph, generated IDs is equals to model dot generates, the sample is equals to false, but decode. I honestly don't know where this is coming from. Maybe we should ask the AI. let's ask Gemini. Meanwhile, as it's running, let's see. Processed inputs to model type, casting the inputs. Okay. Mismatched data types. Model and the input data. Oh, FP16. All the input tensor is in single position floating points. So float 16 and float 32 is what is causing the issue. Okay. Okay. Uh-huh. To resolve this issue, you need to ensure that the input tensor data type matches the model data type. You can achieve this by explicitly converting the input tensor to half position before passing it to the model. Yeah. So the issue is caused by FP16 and FP32. So the reason we okay, and this I'll give context based on LLMs. So you've heard about like okay the one you have heard a lot is FP16 and int 4 or FP8 as well. FP8 became popular during the introduction of Hopper architecture by NVIDIA. So NVIDIA GPUs have been like optimized for floating point 16, and H100s have been optimized for FP8 as well. And I feel like the Blackwell architectures now can process floating point. Okay, I don't know. I don't wanna assume though. But the one I am pretty sure is H100 can process data of like FP8. Yeah. So the reason is we initialized our model using FP16 to reduce the memory footprint, but the processed inputs are in FP32. So we need to convert the inputs to like FP16 as well, or the data type the model is in. So what we need to do is wait. Let's see when the model is yeah. This was the issue. You see here, we converted the model's type to FP16 because the GPU is available. So when we print the touch D type, uh, D type, it should, yeah. So it's touch float 16. So if we remove these and we load the model in FP32, the error will go away. But we still want FP16 to reduce the memory footprint. So what we are going to do is convert the inputs. So we're going to delete this. We're going to convert the inputs also to FP16. So let's see. To the model's D type. Oh, the mod. Okay, we don't want to always convert to FP16 though, because when you have CPU, it will always be like float 32. Yep. Since it's an NVIDIA GPU, an NVIDIA GPU developed to be optimized to optimize FP16 operations. Yeah. So yeah, exactly. K value for KV in processed items, but that's just overkill. We can use the one suggested here. Yeah, let's see. Let's see if it will solve the issue. Hopefully it solves the issue, but yeah. Hopefully it solves the issue. Thank God it has solved the issue. And it's actually pretty fast. Okay. 29 minutes. We are not going to wait here for 29 minutes though. That was a lie. You can see it keeps on changing, yeah? Yeah, but you're not going to wait for it. You're not going to wait for it. So we are performing inference. I hope you have learned a thing or two. So let's learn more about the floating positions, or the yeah. Did they give us like citations? Um, Precisions in GPU processing. Oh, Oh, my bad, my bad, my bad. My explanation was wrong. So CUDA natively supports single and double precision floating point types. So e.g. floats, double, three, float four, etc. But it does not support natively. Natively, it does not support half type. Like it does not support FP16, 8-bit, 16-bit integer operations, etc. So it does precision truncation, half precision. Now the float 16. So FP16 to FP32 and FP32 to FP16. Um, need to get data into FP16 format, copy to 32-bit data to device, do setup kernel before actual computation, create FP16 on host. Bro. Okay, I'll just link it on the descriptions. To the curious ones, you can go check it out. Yeah. Yeah. Okay, it's pretty fast. I don't know why when I was like running the large one, it was taking almost 2 hours. Maybe it's because I'm running the smaller one. Maybe it's because I'm running the smaller, but we'll see, we'll see, we'll see, we'll see, we'll see. Um, so what has remained is creating the submission. Only that. And call today a successful stream. So create a submission. And after this stream, just go and hunt. We are not going to try any other model, but remember my 0.42, my 0.42 score is from like a model I got from Hugging Face, a Whisper model I got from Hugging Face. So go hunt for them, try all of them. Then yeah, tomorrow we'll see how to fine tune our Whisper model. We'll walk through the training notebook. And on Thursday, we evaluate our fine-tuned models. But the problem, it requires a lot of compute. It requires a lot of compute. That's the problem. Or you reduce the data size. Yeah, that's the problem now. So I really wish that everyone here had enough compute to try the experiments with me. Sometimes I leave the experiments to run overnight. But if you have the free tier like Google Colab, you won't be able to run the experiments all night because the session will terminate. You know how Colab is. Maybe run it on Kaggle actually, and then use the save and run all option. Yeah, so that you can run on the Kaggle clouds. Yeah. Yeah. So save and run. Yeah, you can use Kaggle. So we prepare our submission file. Okay. Okay, but we don't have the ID. What we have is the file name. Yeah, and then so here is where we are using here's where we are using pandas, Wayne. So yeah, dollars is overkill for this. So results the items columns is equals to, we need to pass in file name and the text. It should be in the same format as provided in the evaluation. Yeah, file name and text. And then as usual, we save it using the model name. So sub.2csv, baseline, fstring, cfg dot model name dot replace underscore. Due to these two, We need to convert this to single. Um, index is equals to false. Okay, 15 minutes. Are we going to like wait for 15 minutes really? 16? Nah. Yeah, but basically that is the baseline notebook. Yeah, and there are many open. I mean, there are many whisper models to be honest. Um, yeah, you can see all of these except these ones. Okay, Swahili is SW. The ones with the SW, those are Swahili models. Right now we have tested which one? Which one is it? Oh, we have tested the smaller models. The smaller model. This is a small whisper spawn. All of those are large versions of this. Yeah. And actually the 0.42 is one of these. Yeah, one of these right here on the top. Also, one other thing I can tell you to read about is greedy decoding and beam search decoding. Yeah, greedy decoding and beam search. We have to wait for another 9 minutes. So as we wait, uh, anyone with a question, anyone with cool things to share? Yeah. Anyone here at Indaba? Anyone at Indaba? Even if you're a virtual attendee like me, I'm attending Indaba virtually. But sad we are not allowed to like participate in the competition. Oh, no problem, no problem, no problem. I also wish I had attended as well. Yeah, maybe I will also attend next year's. Like I'm following it virtually, and it's actually pretty cool. A lot of cool African research is getting presented there. The keynotes are amazing. Like yesterday, I listened to one by what's that person name? Um, he was talking about AI for science and what he's doing with his company. I think his company is called Casp AI, and his keynote was extremely good, bro. Yeah, this guy. Yeah. They're doing really cool things. Cusp AI is the frontier AI company on a mission to solve the breakthrough materials needed to power human progress. His keynote was about saving the. It is about climate stuff. Yeah, I cannot remember well, but his keynote was amazing. Yeah, and he presented some of the work they are doing. Yeah, you should check it out. I think Indaba posted it on their YouTube, or I think so. I think so. Or maybe they'll post after their conference. Yeah, 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 yeah. Actually, I mean, you're already doing great in this competition. Like maybe after this competition ends and you're still on top, yeah, you can create a paper. You can create a paper and yeah, go talk about it. Damn, the gap here between the top three and the below three positions is crazy, crazy. I want to like really get involved in this battle. I can see you and Brainiac are really fighting, man. You are really, really, really fighting. Mohammed is coming as well. Mohammed too. He's actually a pretty good competitor. Yeah, I think he's even better than me. Um, yeah, 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 yeah. Oh, and the microbiome one. I already downloaded the data now. Yeah, I should like first. This is the high priority competition since it's ending in like 26 days. Oh, like the other guy was removed from the leaderboard. The other guy with like 2.9. Why hasn't this been removed though? I remember the last time we checked, there were two people with like these crazy scores. Yeah, this competition is crazy, man. For real, for real, for real, bro. I even thought it's the polygon stuff. Like, how did you handle the polygon stuff, bro? Did they fix the polygon issues? You mean like where is the bottleneck? For me, I thought like it's the polygon which is the bottleneck for now. Like, where should? Okay, okay. Maybe I don't know. I don't know. I don't know. I don't. I don't know. Oh, really? But I've seen like people like struggling. Okay, I haven't looked at the polygon data yet, but I've seen people struggling. Oh, cool, man. Cool, man. But wait, wait, wait. There was a discussion by not this one, but not this one, but where was that? Okay, I don't know where that discussion went. Yeah, there was someone who was saying like, okay, this. Have you tried drawing a geometry polygon from the chain.csv file onto an image? And it fits perfectly. If it fits perfectly, then I feel like that's what all we want. But I thought maybe the polygons don't fit well because of this discussion. There was also another one here. So like he was saying like the coordinates are in real world spatial units, not in pixel coordinates, but there's no georeferencing or transformation information to map this to the image space. You need a 2D mask, so polygons are not necessary. Oh, okay, 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 okay. I'll be serious. I'll be serious and do these competitions. Yeah, I'll be serious. But there's still a lot of time, man. There's still a lot of time. Like we haven't even gotten to like the October. Yeah, we haven't gotten to. Okay, we have. There's like 2 months remaining. Yeah, so cool, 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 cool. Anyways, we're about to finish. But that competition, all these three competitions look so fun, honestly. Like these three competitions, and they are paying so well. They are paying so well. Like that should be an incentive enough. 12,000. I mean, you only need this competition to beat my ranking. Ah, yeah. No, no, you need more. You need more. But I need to like add to that lead though. But yeah. Okay, so we have finished in France. Yeah, 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 yeah. So this should be okay. Transcription. Okay, okay. Let me finish this, then I'll tell you how I got those points. You just need one. What? I mean, where has the transcription gone? And we have it, like we had it at the inference tab. Uh, nah, I'm not going to repeat this again. Where has bro? Like I mean, you can literally see the transcription here, but when I check the test data set again, it's not there. Oh fuck! I needed to assign it. Sorry for cussing. I needed to assign it, man. What the heck? No, I'm not. I'm not going to like. Okay, you can do this for yourself, guys. Damn. Sorry, guys. Sorry, guys. I really wanted to make one submission, but yeah. Sorry, guys. You can do that for yourself. I'm not going to like. Oh, wait a minute. Oh, it has used the cache. Ah, nice, 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 nice. Okay, we are going to. Yeah, it has not reprocessed again. Hopefully, it performs well. But remember, there is a model that gives you 0.42 on the leaderboard. So you go hunting. Oh, this is trash. Okay, okay. Yeah, go try these large models. Uh, this especially the first one and the second one. Yeah, go try them. You'll get one with like 0.42 or even better because of the randomness. So I'm going to save this and I'm going to link it on my YouTube. On my YouTube. Now we are going to discuss how I got all those points, and I'm going to discuss it using using you as an example, right? So, um, you see, if you win this competition, for example, you become number one. The goal is to become number one. If you want to beat my score, the goal is to become number one because the points that are okay. If you come here to the prizes, if you come here to the prizes, you will see that there are points to be given. Yeah. So these points decay. They decay over time. and you can read here, and even the calculation, yeah, you can read here. So let's read it together. So you have just taken part in a Zindi competition. Do you know how you get points at the end of the challenge? Today we are going to be working out. Okay, everyone who takes part in a points of prize competition, such as the Barbados one, will receive points proportional to the prize money. If a competition is for 10,000, then there are 10,000 points. For example, the Barbados one, there are 10,000 points because the price is 10,000 USD, unless otherwise stated in the prize section. If you're in a team, each team member receives the same amount of points. So the points are not shared among, like, you and your team get the same amount of points. Yeah, and there's this function that rewards the point based on the position you are in. So you can see, like, okay, Sterling was number 3, Masouda was number 1. You cannot see this well though. Yeah, Sterling was number 3, Masida number 1, Flo number what? Okay, no, Sterling was number 1. Sterling was number 1, Masouda was number 2, Flo was number 3, Asaziola was number 4, etc, 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 etc. Yeah. So you can see Sterling does not receive the top points as they are a team of 3, but after the passcode review, they will receive the top prize. We always encourage teaming up and sharing ideas, as you will be required to work in teams in the working world. Oh, they're not even explaining here. Oh, this is important. To motivate you to keep challenging yourself to learn and develop your data science skills, points acquired will gradually decay over time. So you see, like right now, I have how many points? So I'll have to reduce this. I have like 33 points, yeah? But after a while, if you come back, you'll see that my points are decaying. You'll see me get to like 32,000. So what you need to defeat me, actually you are in a very good position to defeat me. All you need to do is win just 2 competitions. You just need to win this competition and you'll get 10,000 points. So you'll see here, you'll get 10,000 points since you're number 1. But if you're not number 1, you'll get around, if you're number 2, you'll get around maybe 3,000 points from 10,000. So you can see, like, the advantage, I mean, the easiest way to get those points is to become number 1, because number 1 gets all the 10,000 points. So if you get 10,000 points from this competition and you get 25,000 points on this for 25,000, yeah, because points are okay. Also, these are given 10,000 points, but it should be 25,000 points, going by the discussion that you've read. But if you get 10,000 points in this competition as well, you'll have 20,000 points, okay? And then you get another 10,000 points here. You become number 1, you get another 10,000 points. So you have 30,000 points. So while participating in all this competition and become number 1, you get 30,000 points. And now let's see how many points you have. How many points do you have? 166. Okay, you'll still not be on top of me though. But Brainiac has a high probability of like getting to like top 1. Why? If he wins all those 3 competitions that we have talked about, actually if he wins these, he'll get 25,000. He'll be at 25,000 points. And 25,000 points is actually number 2. Yeah, so he'll move from position 7 to position 2. And then he wins another competition for 10,000 points, he defeats me. So that's how the points are assigned, to be honest. How I got that point, I mean how I got to number 1, it's because of one competition that I did and become number 1. It's this partial temporal. This was offering like around, you can see it offered around 12,000 points, yeah? 12,000 points and I got to number 1. So yeah, you can see I was number 1. So I got all those points and became number 1. Yeah. But before I won the spatial temporal competition, we were all at around 22,000, 21,000. Me, Mika D, Julius, we were around there. Then when I won, that's how I got that huge lead. So if I want to retain my lead, I have to win these competitions. Either one of these competitions. If I win either of these competitions, then I'm safe. Yeah. So that's how you protect your Zindi points. Okay, guys. Thank you for joining the stream. We're going to see each other tomorrow when we discuss the training notebook. I hope you enjoyed the stream. Adios, and thank you for 20 followers on stream on Twitch. The goal is 25 by the end of this month. So tell your friends to follow me, man. Tell your friends to follow me. But really appreciate you guys joining. Thank you guys. And also don't forget, go test all these whisper models that have already been fine-tuned. And also, yeah, tomorrow we are going to talk about the training notebook. Bye guys, bye.